lines. So we already have our 6 equal divisions, so we don't have to worry about anything else. So now I'm going to take my ruler, I'm going to draw horizontal lines corresponding with my 6 points. So 1 would be the lowest, which is also 30 degrees, and so on. I'm quickly going to draw in those divisions. And there we have our first 6 marks for our graph. So for the next part, I am going to use a flexi curve. You can also use a French flexi ruler. And I am going to connect all of these dots. Always remember to take your time when it comes to a flexi curve. Almost there, and then something moves every single time. I have about the right place now. Ah. And that is only a perfect connection. Very proud of myself over there. And now we are finished with our first half of our graph. So next we are going to do for the next part. So it says over the next 60 degrees the follower falls 29 millimeters with a uniform motion. Uniform motion is easy because that means it's just going to be a straight line. So we know that our total height is 58 millimeters, and the half of it would then be 29 millimeters. If we look at what we did here with our harmonic motion divisions, we know that that is our half point. How do we know that? Because that's where we drew the line for our compass. So I'm just going to draw this line straight through. There we are. So over the next 60 degrees, that would be 2 divisions. So 1, 2. That is where our follower falls and ends. Going to draw a straight line with my ruler, and there we have it. So the next part is the follower will then rest for the next 60 degrees. A simple rest means it's going to be a straight horizontal line. So I'm going to draw on our division line we've already done here, a straight dark line, and then for the last part the follower returns to its original position. So whenever it states returns, it means goes back to where it started, or obviously. But our 0 degrees and 360 degrees would always be on the same point because it is always, it's basically the same place. So I'm going to take my ruler, just finish this one. And now we are almost finished with our entire graph. So for the last part, we're just going to label the graph, which would be, I'm going to take my erase stencil over here, and I'm going to use this open part because that is 5 millimeter height, and you always want to try and write in 5 millimeters. So we're going to label it by calling it our displacement graph. Quite in the middle, but it's fine. And then you always have to use a scale, which would be, so if we look at the scale, we're going to look at the details that were given in the instructions. So we know the horizontal scale is 72 millimeters for each 360 degrees. So I'm going to write that down just as it is. Horizontal scale or just normal scale, 72 millimeters for each 360 degrees. It's a bit off center, but it will do. I'm just going to underline this, make it look a bit neater. And that is the end of our displacement graphs. So now we're going to continue by drawing our cam follower and our cam shaft. So in the beginning I said I'm going to explain why I chose a specific height, and this is where it comes in. Once again, you can go back to our the question I showed earlier, but now I'm quickly going to explain why I chose this height. So we know from the instructions or from the dimensions given that our cam follower is about 67 millimeters. Not about, it is 67 millimeters. So I'm going to find the position for my cam follower. I'm going to use this open space here on the right side of the paper. I'm going to just guess where the middle is. I'm going to draw here, and I'm just going to draw a vertical center line and draw it straight through the page. I'm about there, I'm happy here. So I'm going to have to draw my follower corresponding with my graph. So I'm going to project this through, and that would be the start of our camshaft. So, sorry, follower and the camshaft as well. So that would be my 0 point, my starting point. Now if we look at the graph, my starting point would be in the middle of the circle of the follower, roller pin follower. Why? That is how we draw a roller pin follower. So you can see there it's going to be 60 millimeters height from point 0. So I'm going to measure 60 millimeters right there. And it is 8 millimeters wide. We're going to measure that. That's going to be our width. So our the end of our roller pin follower is going to be 7 millimeters. So with it being that small, sometimes I just use my circle stencil. It also saves time, so I'm just going to draw the center line here. You can see, so I have a radius of 7 millimeters over a diameter of 14 millimeters. So I'm going to use this circle. We have our points, and I'm going to just finish the follower. And now we have our follower. So now we're going to have to find and draw the center of our camshaft. So that would be 23 millimeters from the center line, center of our roller pin. So it's 23 millimeters from here. Going going to draw center line for it. So the next part, we know this is a diameter of 18 millimeters. I'm thinking it's quite small, so I'm just going to use my stencil again. There we have it. So for the next part, we're going to look at our specifications in the top. So we know the rotation is anti-clockwise. So I'm going to take my compass, open it a bit bigger than my center point. I'm going to make a line. This is going to be an arrow to indicate our direction. So I'm going to make just a small triangle at the top so we know it's going anti-clockwise.